Alright, so this is going to be our next notes in algebra, and this is going to be talking about something called arithmetic sequences. So arithmetic, you're usually talking about addition, subtraction, multiplication, and division. And so we're looking at those processes and then sequences within those processes. And we have a definition here for sequence. It's a set of numbers or terms that are in a specific order. Okay? But also within that specific order, there's a constant change from one number or term to the other. We call that change, if it's constant, and if it's always the same, we call that the common difference, and they abbreviate that with the lowercase d. So we're going to look at a few examples to I'm going to show you a few examples to see if you can, to help you understand the different examples. And you look at example 1 here. So we have a distance and a time. And we have a distance of 400, 800, and 1200. And then we have a time, 132, 304, and 436. And we can look at both sets of these numbers and see if they're a sequence. So we can look at 400 to 800 to 1200 and see how they change. So 400 to 800, that's 400. And 800 to 1200, that's another 400. So we could call this a sequence. We then look at the next one, 132, 304, 436, and we might say, well, is there constant change? It might be easier to look at the second one, 304 to 436. How much does it change? And that would be, if you looked at it closely, be a minute and 32 seconds. So then we have that. And then we'd want to see, well, does that fit the one before it? And we'd see if we had 1 minute and 32 seconds to 1 minute and 32 seconds, we would get 304. So that's an example of a sequence. And the common difference with this one would be 1 minute and 32 seconds. The common difference D with the top one would be 400. If we look at another example where we just have numbers, example 2, we would look at a sequence. These are a set of numbers, 3, 5, 7, 9, 11. And then it just says these little dots here mean it can go on forever. And so we look at 3 to 5. We look at the change here. We're looking for is the change a common difference, where the change is always the same between each number. And as we go to 3 to 5, we would see 2. 5 to 7, we would see 2. So the common difference for this one would be 2. Look at another example here. And we have 33, 29, 25, and 31. And again, it just goes on. And then you look at each one, the change. We know 33 to 29. These are easy ones. They won't always be this easy. But there's a 4. Then we got this one, 29 minus 4 is 25. 25 minus 4 is 21. So that's our common difference there. We'll just call it D this time. That's D. Okay. So that's an example of a sequence and the common difference that can exist. So if we look at how this can then be applied, there's actually an equation that we can derive or we can use when we want to figure out numbers in that sequence. Because you can see, if I go back here, you can see that if I just want to know what the next number is, 11, and I'm just increasing by 2, it'd be 13, and then it'd be 15, and 17, and that's like, the second, third number, whatever in the sequence after 11. What if I wanted to figure out the 100th number in the sequence? I'd have to do all that out. Well, we can actually derive we can use an equation to derive what those values are. So if we look here, so when we look at these terms, these sequences, each term in the sequence can be expressed in the terms of the first term, A1, and the common difference, D. And we're going to look at some examples here. If we just assume something to help us understand this, if we said the first term, A1, we'll just say it's 8, and then the difference between the following numbers is always going to be 3. If we set that parameters up at the beginning, we can see how, I can show you how an example of how you can get this equation that we're going to look at here in a minute. But if you look at the first term, so if we're just looking at some examples, so the first term we say is A1, the symbol for it is A1, and then there's A plus D, so there is no difference yet, so it's A plus 0, and then, so then the number would be 8 for A1 plus 0, and it's 8. Okay? But then really what we want to do is figure out some additional terms in this sequence. So when it becomes much more valuable. If we know there's a constant change occurring, then we can figure out numbers way down the line if we had the right equation. That's what we're going to look at here next. And so then let's say we have the second term, A2. And A2 is really just A1 plus one common difference, the common difference one time. So that would be 8 plus 1, and the common difference is 3, so 1 times 3, we add them together, we get 11. So that would tell us the second term in this would be 11. The third term, if we wanted to do this, would be A3, so that would be A1 plus 2 times the common difference, 3 times, that'd be 8 plus 2 times 3, or 8 plus 6 is 14. So we know that third term would be 16, just by doing this math. But there's actually an equation for the nth term, which can be any term. If you want it to be the 112th term, if you want it to be the 1000th term, the millionth term, we could figure out what it is by using this equation. Okay, so this is the nth term, that's what the an means, equals a1 plus n minus 1 times d. Okay, so this is going to tell us what the number is. We just need to know what the starting number is. And then we just need to know which one of those numbers do we want. The 35th, the 2nd, the 5th, the 20th, whatever. And then we just need to know what the common difference is, and we can plug this in to figure it out. So let's look at an example. So this one says, write an equation for the nth term of the following sequence. Negative 12, negative 8, 4, and 0. Now if we just wanted the next term, right, we could easily figure this out. Looks like they're adding 4, right? So the next one would be 4. Okay, but they want to know what the nth term is. Okay, so and that's going to help us figure out, because we have this general equation here. So these are all going to be a little bit different based on what we start with. We have this general equation here, and then we can use that to figure out exactly what the algebraic or the equation is to solve for an unknown. And I'll show you in a minute here what I mean by that. So if we look at this, so to write the equation for the nth term for this one, we find out what a1 is. We know the first number is 12, right? That's that one. And then we find the common difference. We figured that out, right? That's 4. And then we plug into that equation that we started with. So then, and that just tells us the equation for the nth term, a of n. So that equals a1 plus n minus 1 times d. So then we plug the numbers in. an equals negative 12, that's our first term. And then, so you see that there, first term, right, negative 12. Okay, and then, so then we have that negative 12, and then we're going to add n minus 1 times 4. Okay. We don't really know what n is yet, because we're just seeing, well, what is the equation if we want to figure out this nth term, whether it's the 9th, the 20th. We can figure out the equation for this set of this sequence. They're not all the same. So then we plug in, then we do the math. So we'd have negative 12 plus, and this would be 4n, right? We're multiplying during the distributive property here, right? So 4n minus 4. We then collect like terms, so we take this negative 12 and we would add it to negative 4 and we get negative 16. So then we know the equation for the nth term of this set of numbers is going to be 4n minus 16. So then if we want to find the 9th term, we then use that equation. The a of the 9th equals 4, right? 4 times n, it's the 9th number, minus 16. We would then get 36 minus 16, and we would know that number is 20. Okay. So we have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We're way over with that. So we have these first 4. If we added 5 more, we would see at the end of adding those 5, it would be 20. And we don't have to do all that calculation or anything. So that's an example of using that equation and solving, using that basic equation and solving for the equation for that sequence. There's one other thing we want to look at, and that's graphing sequences. It's probably going to have you do this, and the homework is, I know. So we can then take these numbers and then graph them, and then if we had a linear graph, if the change is constant, which it is, right, we know the common difference is always the same, we could then draw a graph and figure out what the other numbers are. Okay, so we would then start by putting the nth term, the x, on the x, and then the number sequence y, or a of n, on y. Okay, and I kind of labeled them here so you could see them, a of n and n. Okay, this would just be just like a regular coordinate plane, so I'm going to add some numbers here. There's some slashes so I know what I have. Okay, so I have those. And then, again, the nth term would be x, and then the number in the sequence y, a of n, is y. So then we want to graph these, right? So we want to know the nth, right? So we'd have the first nth is negative 12, right? And that would be the y. So we would put it on negative 12. So we'll make this 2, 4, 6, 8, 10, 12. It'd be right here, 12, and then it would be over 1. So that would be our first one. We move it up a little bit. So we'd see that the nth, this is the first nth, and this is the a of n, or the number of that first nth, would be negative 12. Then we would do the second one right here, and we would say it's negative 8. So 2, 4, 6, 8. That would be a dot over here. Probably should use graph paper. That's fine. And then negative 4 would be the 3. So 2, 4. It'd be the 3. Some more dot over here. And then we would do the 0 would be the 4th. 1, 2, 3, 4. It'd be about right there. And then we could just draw a line through this, and I don't have a ruler in front of me, but I could do that. And then I could just follow this line. I could draw this line along, and I could see, based on where the nth is, if I had a big enough coordinate plane, I could figure out what each number is just by reading the graph. And that's an example of that. So I want you to try your or make sure you get these notes written down. These are about arithmetic sequences. And we're going to do some more practice problems in class tomorrow. Let me know if you have any questions about the notes. You can even add them to the YouTube video, like put the questions in there. That'd be really a good thing to do. I can look at them before class and know what to answer as well. So let me know if you have any questions.